My name is Robert Kennedy. I'm an assistant professor in the Department of Earth and Environment at Boston University. All of these images are numbers. Now we can display them on a monitor as different colors, but what we work with analytically are the numbers themselves. When we're looking at how processes affect landscapes, you need to understand how the processes unfold over time. Hindsight's 20/20. Landsat gives you that hindsight. In the Pacific Northwest, known for its timber, right, for producing lumber. So you've got a stable forest, and it looks kind of the same to the satellite over time. Then you come along, cut down all the trees, boom, it's a lot brighter. And so you can think of subtracting one part of the information. And the other thing is that you've revealed something new, which is the soil, the rocks. We added this soil in there, this signal that it sort of bursts out at you like a flag. That soil signal that was there, that you saw right after the clear cut, immediately starts getting obscured. Grass will come in, shrubs will come in. So as that happens, the soil gets covered up, and so you can actually watch that whole process happen, from an older forest to this bright soil to recovering vegetation. So the progression in the bark beetle is we have a fairly stable lodgepole forest. There'll be sort of an explosion, an epidemic of these beetles. Our color scheme kind of goes from stable forest, which is in tones of blue, this bright red coming from the soil and from branches and things that are revealed when the trees lose their needles and when the needles change color. One of the insects that's increasingly important is a western spruce budworm. They don't go in and kill the tree outright, but have come in and eat the buds or the young needles off a tree. And so the satellite sees that as a bit of a darkening of the picture over time. By the end of the time period, we see pure yellow, and that's associated with broadleaf shrubs. It could even be a shrub field, just dense. Those bugs have changed the environment for everything else there, and the everything else there in this part of the world are shrubs, rhododendrons, other shrubs that are usually hanging out underneath the trees where it's kind of dark and shady. Boom, they get all this light, they love it, they grow like gangbusters. One of the interesting things about managing forests in the Pacific Northwest, you can see a very strict delineation on your landscape from the satellite's perspective, and that's just a manifestation of the policy differences, of the ownership differences. The idea behind science is to develop understanding, ultimately to be able to predict and understand processes. When we look at a change, when we look at those graphs of life histories of individual pixels, it's the numbers that drive everything. It's the numbers that we use to look at how severe things are. It's the numbers that we use to quantify how long did it take, or when did that start, or how big was that clear cut. The Landsat perspective is really the only tool that lets you look at what's going on at the scale that you're interested in, where you can see individual events and harvests and roads and houses, and at the same time look at the whole landscape.